Last one. This one, a particle moves along the x-axis so that at time t, its position is given by this function. Oh, look, a little different notation this time. Instead of s, we used x of t. Totally okay. We can use any variables that we'd like. We just have to have them communicated clearly. We want to first decide if the particle is moving to the right or left at 0. Well, the velocity is going to tell us that. So we need to take the derivative of the position function in order to find the velocity function. And then we're going to evaluate that at 0 to determine the time. Or to determine the sign of the velocity, which in this case is positive. X prime of 0 is greater than 9, so we are moving to the right. (13) At x equals 1, is the velocity increasing or decreasing? All right, this one people really struggle with. The common mistake that people do is they take a velocity function like we just did here, and they evaluate it at 1. And they use the sign of that answer to answer this question. They're missing the importance of the words increasing or decreasing. It didn't say, is the velocity positive or negative? It said, is the velocity increasing or decreasing? Whenever you see increasing or decreasing, these are languages for a derivative. We are interested in seeing if the derivative of the velocity is positive or negative. That's really what this is asking. Not, is the velocity positive or negative? So we already know what x prime is. We're not interested in velocity. We want acceleration, the derivative of velocity. So we are going to look at the second derivative of the position function and evaluate it at 1. And this is something that students really miss, that language about increasing or decreasing. But since this ends up having a negative sign, what we could say is that the velocity is decreasing. Because the slope of the velocity is negative, that means the velocity is decreasing. We want to find all values of t for which the particle is moving to the left. Well, we know that what that looks like is that that's where the derivative is negative. That's where x prime is negative. To decide where x prime is negative, I'm actually going to take x prime and set it equal to 0. Because if I can find out where it equals 0, then I could use an alt table to determine the intervals. So this one can factor with the GCF first. And then I can factor that trinomial. There are 2 places where the velocity is equal to 0. And so we could have some sign changes here, which will help us see if the derivative is positive or negative, and that'll give us the direction for the particle. I'm going to make an alt table, but I do want you to notice I'm not starting time at negative infinity. That's not going to make any sense in the context of this problem. I'm going to start time at 0. And then I'm going to look at x prime and look at the sign of x prime in each of these intervals. If I test something like a half, I get a positive times a negative, leaving me with a positive, and this tells me that the particle is moving to the right. If I pick something like 2, I get positive times a negative times a positive, leaving me with a negative, and the particle is moving to the left. If I test something like 10, I get all positives multiplied together, and the particle is moving to the right. So the values of t, where we're moving to the left, would be on the interval from 1 to 3. That's not an ordered pair, that's an interval. Sometimes you'll see people write it as an inequality instead. I guess I would use open like that. At 1 and 3, it actually is stopped because the time is 0, or because the derivative is 0. All right, at time is equal to 2, is the speed increasing or decreasing? Well, we can find the answer to this if we examine what's happening to the first derivative at 2 and what's happening to the second derivative at 2, because we would want to see if the velocity and the acceleration have the same signs or not. So I have an equation already for the first derivative. I'll just substitute in a 2. I really don't actually care numerically what the value is here, just the sign. but I get 12 minus 24 plus 9 is negative. I think it's negative 3 on that one. And then if I check at 2, let's see, I would get, oh, you know what? I remember I wanted to change this problem. Can we change this to 3? Because this question ends up not being a very interesting one because we end up with an acceleration that's 0, so it's not increasing or decreasing. Let's change it to a more interesting time where we can maybe find something more useful. If we use 3, and I plug that into the graph of, or the equation for velocity, let's see, 27 minus 36 plus 9 ends up equaling, I don't know, what does that even equal? I'm doing fantastic. 27 minus 36 is negative 7. Okay, this is positive. You guys, I probably did that wrong. My life's ruined. X double prime of 3, I would do 6 times 3 minus 12 is also positive. And so because I have the same sign for both of these, so x prime of 3 and x double prime of 3 have the same sign. And so what that tells me is that the speed is increasing. If they'd had different signs, then I would say they're decreasing. And I am going to list the time at t equals 3. I'd like you to notice my notation here. I didn't say x prime of t, because x prime of t has different signs at different times. I'm being very, very precise about the time I eventually decided to ask the question on. All right, that is the end of the notes for section 3.6.